Hello. In this video, we will take a look at Chapter 7, which involves crustal deformation. So looking at what can happen in the rock layers. And then I'll do a second video on mountain building. So there'll be two videos associated with this chapter. So when we talk about crustal deformation, you see here it's a term that we use to refer to all of the changes in the shape or position of a rock. And this is going to be in response to some type of stress. And when these rocks that make up the Earth's crust become deformed, we will see different types of features. We can see folds, faults, and joints. So there's a smart figure associated with this, and we'll talk about this more in the lab. But what you see here is instead of seeing these rock layers that are going to run, parallel, you see these kind of dips and these folds that are occurring. You also see a big break or crack here. And if we look at this sketch down here, we can see several different types of deformations. We can see a syncline, which is a deep, V shape here. We can see the anticline, which is kind of an upside down V. This break or fracture in the rock here is called a fault. And then over here, we can see another type of fold, not quite a syncline or an anticline, but just another fold that has occurred here. So why do rocks deform? Well, it's stress. As we talked about when we were talking about the formation of rocks, we know that stress is one of the factors that allow us to transform, an igneous or sedimentary rock into a metamorphic rock. But stress isn't just transformational, it can be deformational. So there's compressional stress, which is squeezing. Tensional stress is the pulling apart. And shear stress is almost like a slippage that is going to occur. So here's some, these examples here. So confining, being pushed in, and this can be from, more than one side. So if you think about compression and it squeezing it, the squeezing can occur, from a left-right direction, or it can occur from a top-down or bottom-up type of compression. Tension and stretching, same thing. It can be, kind of a parallel process, or it can be a perpendicular process. Shear is more of a sliding. Shear is very similar to what happens at like a transform fault. Remember, in a transform fault, one piece of the plate is going to move, up, and the other is going to move down. And that's kind of what happens in shear. We get kind of this parallel motion, but the top of the rock is moving one direction and the bottom of the rock is moving the other direction. So if we look at deformation, we can have elastic, brittle, or ductile. Elastic is what we think of, with a rubber band, essentially. You can stretch a rubber band and you let go of it and it'll go back into its original size and shape. And this is what happens in elastic deformation. The rock can be, stretched or pulled, but once the stress is removed, it can go back to its original size. However, if that elastic limit or the strength of the rock is surpassed, then the rock bends or breaks. Same thing with a rubber band. If you pull too hard on the rubber band, you'll break it. Or you'll stretch it out to the point where it doesn't go back to its original size and shape. So bending is ductile deformation. Breaking is brittle deformation. So what are some of these stresses that can be placed on rocks? Well, temperature. You see their higher temperatures cause more of a ductile or a bending deformation. Cooler temperatures causes brittle or breaking. Confining is when the rock layers are squeezed closer together. This makes them harder to break, so we get less brittle deformation, but we can still have ductile deformation. It varies on what type of rock we have. Is it a crystalline igneous rock, or is it a sedimentary or metamorphic rock? Igneous rocks tend to break more than they bend, whereas metamorphic and sedimentary are more associated with bending, the ductile deformation. And then, of course, just time. Over time, we can get ductile deformation. And so here's, some examples here, and we can look at the different depths where this happens and whether we get compression, tension, or shear. At shallow depths, it tends to be more brittle, so we get breaking. At greater depths, we get more of this folding and bending. So a fold is basically like a wave within a rock. And this is typically from compressional stresses, as you see here in this folding. So anticlines are upfolded. So with anticlines, you're going to get kind of this upside down V or upside down U. And the oldest strata are going to be in the center. So you took something that was flat, so you have all of these layers here. And we know that the oldest layers are down here at the bottom. So this would be our oldest layer here, because we know that as rocks form, we have layers that form, and the oldest is going to be on the bottom. So when we get bending, and so how this is going to bend is bend downward on either side, then what's going to happen is that purple layer there, my oldest layer, is going to wind up in the center. So the oldest strata are in the center. But when we look at what happens in synclines, and the way that they are folded, so let's do our layers here. They're going to fold the opposite direction. So they're going to fold this way. So when they fold, the youngest are going to be in the center. And then our oldest layer, which is down here, is actually going to be at the outermost part. So with an anticline, they're going to be folded and make like this upside down U with the oldest in the middle. And then synclines are going to kind of fold downward into this V or U shape with our youngest in the center and our oldest on the outside. They can be symmetrical or asymmetrical. Symmetrical, of course, they're mirror images of one another. Asymmetrical, they're not identical. They can be tilted beyond vertical, or the axis of the fold goes, into the ground where we can't really see the entire syncline or anticline. All right, so here we go. Some different types of folds that we're looking at here, and some directional pictures. So here we kind of have this upside down V shape. So this would be an anticline. Okay, so this is an example of an anticline. And this would be an example of a symmetrical fold. These are about in the same angle. Here is an example of a, here's an example of another type of fold. We see this one, okay, our syncline here, we can see is also symmetrical. These are pretty symmetrical. But if we look at this one, if we look at how this is shifted, and it's really hard to see what's going on here because we are overturned. You know, we have gone way beyond vertical at this point. We kind of have a little bit of a normal limb here, but as we go all the way across over here, and you can kind of see where we've got some of these folds, this is an example of an asymmetrical or an overturned fold. So these are a little bit harder to pick out. The symmetrical folds are a little bit easier to see when you're looking at different pictures. Once we get to asymmetrical or overturned, they're a little bit harder. We can also have some domes and basins, and we'll take a look at these in the lab. A dome is an up warping, okay? And just like we saw with the anticlines, the oldest strata are going to be in the middle. A basin is more, down warping, and in this example, our youngest strata will be in the middle. And again, we'll take a look at these in the lab. They're a little bit harder to see when you're in a two-dimensional structure, but as we look at our topographic maps, this will be a little bit easier to see. Some other examples we can have is what we call a monocline, is where we get some folds that are in an otherwise horizontal strata. So you can see how all of these layers are just running right on top of one another, right? They're these pretty symmetrical lines. And then all of a sudden we get this large little dip that happens. The strata are still symmetrical to one another. We can still see these layers that are symmetrical to one another. But we've got areas in this little area right here where some of the strata have been removed. And we've got a fault that has occurred. So we've got this upwelling here. So we get this bending. Still considered, horizontal layers, but we call this a monocline because we end up getting a fault, and so these are kind of pushed apart. And sometimes these are a little harder to see due to erosion that has occurred. Now looking at brittle deformation or the breaking, we can have joints or faults. Of course, we know with faults, this is where motion has occurred. This is where a lot of our earthquakes are going to happen. And so what happens is you get a break in the rock. So we can see this fracture that has occurred within these rock layers, and we can also see where we now have offset here. So here is a particular layer that's on this side, and over here it's on this side. And so we use these arrows to indicate the direction of slip. And so what we're saying is that this side over here has moved upward, and this side over here may have moved downward, so that we get this offset layer. We can have different types of faults. We can have dip-slip faults when the movement is parallel to the incline, and we get what are called fault scarps as a result of this because of the vertical displacement. So here's our footwall block. This one has been shifted upward. Here's our hanging wall block. And you can see, if we look at these particular layers right here, we can see that they are identical to one another. But because of this dip-slip fault, we have now separated those. And it's kind of hard to see here, but here's this fault scarp. And essentially what happens is we're exposing this layer here by this particular part slipping downward. Large-scale faults can be associated with fault block mountains. So we can actually form mountain ranges based on this.